Hey everyone, welcome to the first video of 3D graphing. As I said in the last video, which was a Q&A video, or like just like an FAQ video, um, I believe I mentioned that this is going to be an orthographic projection. What I mean by that is the way to convert 3D points into 2D points is simply by ignoring the depth value, right? It's going to feel weird, but this is the easier version of 3D graphing. If you want a more realistic one, where we actually add a perspective, that may be a later series, but I'm not going to go into any more detail of that. Let's get on with this one. So what we're going to be doing, I'm going to call this 3D graph, and I want to get you guys started with a simple cube in orthographic projection. So we can still define vertices as how we would define it in 3D, which is we specify an x value, y value, and a z value. So I'm going to do a quick demo of how that is going to work, because when we pass in arguments, it's going to be, we cannot, so normally when we just plot a point, we just tell it what's the x and what's the y. If we try to pass in a third value, a z value, it's not going to work. So let's actually make a folder for a cube. It's not going to be a cube, it's going to be a cuboid, which means we don't have to have equal length on all the sides. So it's going to look more of a rectangular prism. You can make it a cube by making the width, height, and depth the same. So we're going to define the points around one vertex. So I can't use x because x is reserved, because if I type in x, you'll get a line like that, and if I say x is equal to 2, you'll get a vertical line. So the way we're going to get around it is you can either give it a different name, or you can just, I'm just going to use x0. X0 means the starting x, and I'm going to set that to, I want to make this the origin. So I want to make x0 equal to 0, y0 is equal to 0, and z0 is equal to 0. And then we're going to need some points, so we're going to need, so it's the way we convert this. So since we are ignoring the z value, but we will use the z value in another calculation, which I will discuss later in this video. So let's make some points. To x comma y, it's going to be x0, y0. Let's give it a width, height, and depth as well. So let's give it a width of, let's pick each of them 4 for now. And this one, let's move it over by a width, and we'll leave the y value the same. Okay, so I jumped to recording because I didn't want to waste your time just simply writing in all the points. So you should have a total of 8 points. you should be able to derive them from the width, height, and depth. So next thing that we need is we need a rotation along the x-axis. For now, it's 0. Okay, theta is in radians. Desmos by default uses radians. We can switch to 2 degrees, and that will actually make rotate a lot smoother, because as 2 pi is a pretty small number for us to work with. With personally, I don't know about you, but um, I like having 360 degrees of freedom rather than 2 pi. So we can do that. Okay. Okay, and then in addition, I want to write a conversion from radians to degrees, just to make things easier uh, for us to play with. So the formula, so let's write one of them here. It's going to be, it's good to, I believe is it 180 divided by pi, or is it pi divided by 180? Okay, so this is, okay, I had to look it up real quick. That was kind of embarrassing. It's going to be uh, theta x times pi over 180. So we're going to copy the same thing for both the y and the z, and of course we do need to change this up a bit. Okay, so now if we move, say, the data slider for here around, you see the degree actually changes much more smoothly. Change this to 0. Okay, so we'll come back to that later. First, I want to write a formula for rotation. Okay, so let's start with one of the points. So first rotation is going to be along the z-axis. So this is actually the easiest one, because the way you rotate this is the same as how you would rotate this in 2D space. So I'll do one of them with you, and then I'll fill the rest off cam, and then I'll do the same process for y-axis and z-axis. So let's do the z-axis. Sorry, x and y-axis. We're doing the z-axis right now. So z-axis, that's the axis that coming right at you. So the formula for this one, we're going to multiply this by the cosine 0 cosine if it's not degrees in x, we'll change it to theta. This would be minus y sine of 3 on the x. Complain because y is not defined. And for y, it's going to be y times the cosine of the angle plus x times the sine Okay, so let's check it out. I don't know why I'm being this. Oh, you know what? It's actually got it wrong. It's C. The right reason not doing anything. Okay, I want to diagnose what's going on. I'll be right back. Okay, so it turns out that the point I'm trying to move is actually on the point of rotation, which is why it's not going anywhere. So I have actually added in the rotations for the rest of them. So if we change the z rotation by say 30 degrees, you can see as this thing rotates. All right. So let's. This is kind of bugging me. Oh, this 2 is top at 10. Just like everybody else. Okay, so let's do the y-axis now. Just so we make a difference of on which ones we do next, I guess. So with the y rotation, the only thing we're going to modify is this x value here. But when we modify, we're going to. This is when we're going to be using the z value. Okay, so the way you do this is, so you have this current value here. I'm going to copy it. I copied it wrong. Copied the comma by accident. And then what it's going to be is going to be the current x and then we're going to multiply it by cosine of the rotation along the y-axis. And then with this value here, and then we're going to subtract it by z times sine of this rotation here. We're only going to multiply. We're only going to modify his x value. Okay, since that was slightly complicated, I'm going to show you. I'm going to show you that one more time. This is going to be a straight up copy and paste for this one, I think. Yeah. this one is actually the same thing. There's no point in me writing it twice. Okay, so let me show you on this one, and then I'll let you do the rest yourselves. So we're going to save this value here, and then we're going to multiply that by cosine of the y rotation. Then we're going to subtract it. We'll subtract the z value. Double check here to make sure I put z0 instead of just a z. Right. I hope that makes sense. Once we get to the x, we're gonna have a lot to cut and paste around with. So I'll finish the rest off cam, and then I'll come back. Okay, so you should, if yours works like mine, you should be able to rotate yours along the y. In this case, the vertical axis. So you see, if I choose 80, it's almost fully rotated, and if it's 190, you can see that's you only see one side of it. Okay. Let me change this back. And the last one, we'll rotate along the x-axis. So once we finish all three, actually, in fact, you can, if you want to, you can even I want to rotate 30 degrees along the y-axis. I want to rotate 80 degrees along the x-axis. And this thing will rotate in those two spaces. So the last one is going to be slightly tricky because we're going to be modifying both. We're going to only modify the y value. So we are doing essentially the same thing as we do with the x-axis. To save a bit of time, what I just found they can do is when you highlight what you want to put parentheses around, and then you hit parentheses, it'll throw parentheses around whatever you just highlighted. Did not know about that. I was actually using that off cam, so I'll show you that to save you some time. And then we're going to multiply this entire y value by cosine of the x rotation, and it's going to be minus z times sine of not dy but dz or dx. So do the same thing for all of those. This nice shortcut key should hopefully save you some time, and I'll catch you in a little bit. Okay, at this point you should have everything you need to make a cuboid. So this is a demonstration on what happens when you're done with this. So you can rotate along the x if you want to, 30 degrees. And do I have depth? I think I have depth turned on. Okay. This is what we should have. So if we actually add depth, then you can see that. Okay, now I'm starting to see why things are actually working, because we've got to how deep it is. So now this is actually a perfect 4x4 cube in orthographic projection. Okay, so 30 degrees, and then let's rotate this. I don't know, 40 degrees on the y-axis, and let's go 20 degrees along the z-axis. All right. So this looks nice, but I just thought, hey, you know, what kind of cuboid just doesn't have edges, right? All we have are just a bunch of points that don't really mean anything. So if you want to, I'm going to demonstrate quickly on how to draw lines. I will change the pictures. I don't know why this says constraints on it, and I think constraints are different. It's the only one like that. Okay, so I made a little table here, and I'm just going to cut all of these. I'm just going to move all of these pairs down here. Since it's hard to track on how points connect, I have listed indices which have edges. Okay, so we have 0 and 1. So that is this pair right here. Come on. And that's going to be, and we need still 0 to the next. And then we need index 1. So that is the one right below it. So before anybody starts accidentally messing up, uh, this is from the order that I have it written down. So if you did yours in like a different order on how you define your points, your lines are going to be messed up. So so I do recommend jotting down the indices of the pairs of points that you use before I start complaining that something went wrong because you use my reference instead of yours. Okay, so that's one pair done. So once we finish all this, so we can just take out all these points because as much as I like trigonometry, like just as all of this like big formulas aren't my favorite, and I'm sure there aren't yours too. Like just look at the quadratic formula. That thing is huge. If you don't know what that is, go look it up. So yeah, I want to do the rest here. I'll just do one more on here. Yeah, my next pair is 1 and 3, so that is. Oops. Actually, in fact, I'm still going to grab 3 because 1 and 3 is the same thing as the same word as 3 1. There's no duplicate button here. Well, that stinks. I think if I hit Control A, that'll select all. Okay, Control A selects all. So we'll hit that. We can do mini table, and let's move this like that. turn this on. I want lines. And I'm curious to see if we can just simply grab the whole pair and put it in there. Otherwise, it's a pretty long process. We grab this, and then we put this in here. No, it's not going to let us do that. Okay, I think I even pulled the wrong index. Should be 0, 1, 0, 1, 2, 3. So that's this one right here. Okay, it's a long process. This is a cube, and a cube has 12 edges, which means if you want lines, you're going to make 12 of these. So yeah, give me about an hour, and then I'll catch you back. Okay, so this is not completely done, but just imagine that it is. I will finish it for the next video. So we're gonna do more with it. Yeah. I did do a little bit of graph theory. And I found a simpler way of doing this rather than going through a painful process of doing this, of just making 12 tables. So yeah. If yours doesn't work, do link a graph to yours, and I can help you take a look at it. Okay, so I really like this one. I thought this was pretty fun. So if you guys like it, I would love to make more of these videos because I certainly had a lot of fun with it. All right, so I'll see you in the next one. I hope you have a nice day.